Thanks everyone, and thank you to the organizers for allowing me to share a little bit of industry work with you. So as Cindy mentioned, I work for Syngenta. My title is a data asset manager with a global role. And let me show you first an example of how data can flow in farming, or how we'd like it to. And there's as many versions of this as there are farmers out in the world, right? But got a farmer, might have an advisor involved. We might have crop scouts or other sources of data that the farmer and the advisor are interested in, a service provider maybe, and some downstream partners like a regulatory agency or other downstream partners, maybe a buyer, other kinds of consumers of data. Then that farmer might make a plan where they represent how they're going to grow a crop during this upcoming season, share it with the advisor, share it with whoever's going to collect data with them, might send a history of observations in the field and what has been done before to the advisor. The season begins, these observations and measurements from the field start flowing in. The advisor makes recommendations, the farmer makes decisions, sends the resulting desire to make something happen to the service provider. Service provider makes the field operation happen, planting, crop protection, crop nutrition, you name it. A record of this goes back to the farmer, and then eventually data can flow to downstream partners in the form of reports. Again, there's all kinds of levels of formality and granularity of this, but this general idea of having a strategic plan and then some tactical documents that support that is fairly universal, even if most of these documents are inside a farmer's head. The kinds of data involved here, identifying the farmer's business entity, farms, fields, boundaries, the crops, the products being applied to them, the units of measure and variables involved. We're going to talk about two use cases in here. One is machine data integration. The other is field data collection or scouting. So when you're dealing with machines, you've got all these different types of machines, combine sprayers, et cetera, different sizes and complexities. When you're trying to make sense of what they did, you have to do some math. You want to collect these different points where the machine is reporting what it did, and that may or may not be broken out into sections. So you're performing all these little mass balance things, and it eventually can turn into a map where you have data related to the time, the location of these measurements, the direction the machine was going in, its speed, and the mass or volume that it reported. When you have the boom broken out into sections, this gets a little more granular. A data set of these things is composed of a time sequence of these records, and a yield map, as applied map, or planting map is derived from the records that come from one or more data sets. There are multiple issues with this. There is a lack of common formats. For one, the data is often available in a proprietary format only. This problem's gotten better in the last few years. There's a standard called the ISO 11783 Part 10 that is being used more. And then there's a tool called ADAPT that's being used to convert formats. We'll talk about those a little bit more. A bigger problem is the lack of common meanings or common semantics. Although placing the data in space and time is relatively straightforward, Problems arise when you're trying to do other things like identify the products that you applied, identify the crops that you're working with, identify what field operation you're performing and who was involved and what role they had, and what the units of measure are for all these things that you're reporting. And also sometimes what the variable was. Is this a yield? Is this a rate? And not only that, but the data itself is messy with machine data integration. You have all kinds of artifacts from interaction with the GPS, when you change speed. It's a messy kind of data. When you're trying to do field data collection, the problems are somewhat similar. Again, you have a lack of common formats. Many field data collection apps are often closed loop systems where data export is implemented as an afterthought, if it is at all. And again, we have a lack of common semantics. When these systems do export data, it's sometimes in HTML or PDF. And when they do export, it's often in poorly documented CSV files or poorly documented JSON in best case. So despite that, again, time and space are often recognizable. Time zones, not so much. And again, the problems arise when we're trying to identify things like the crops and varieties being observed, features of interest, like are you measuring something in the air? Are you measuring a sample in a leaf? Things like that. The observed properties, and observation methods, aggregation methods of your data, and units of measure. Again, quite complex. Going back to our core documents, the way that this has been modeled is saying, well, these core documents typically refer to a set of resources like pieces of land and pieces of equipment and people and variables and so forth in what we call reference, setup, and configuration data, 3 sorts of categories, where reference data pertains to things like crops, products, operations, roles, units of measure, variables, things that describe all instances of a thing that are typically infrequently changing. But unfortunately, that often doesn't work very well because everything's fine and dandy when the IDs are minted by reference data providers. But when they're minted by farm management information systems, or even worse, inside the machine cab, recognizing these things when you're trying to do something with the data becomes very difficult. Regarding the setup or master data, this tends to be farmer specific. So it describes a particular instance of a thing, typically doesn't contain state information. It might change, a field boundary can change, what you are calling my, homestead farm might change and so forth. The IDs are typically minted in a farm management information system by the farmer or an advisor or a retailer of crop inputs. Configuration data is also farmer specific. It describes the state of a particular instance, like when you have a machine connected to an implement, or you have put a GPS unit somewhere on your machine, and you have to describe the offsets so that your observed data is spatially accurate. And here, the IDs are typically minted in the machine itself. Imagine a very busy person fat fingering something on a membrane keyboard. That often doesn't go well. So I mentioned AgGateway in my title. It's a nonprofit consortium. Its mission is to promote, enable, and expand digital agriculture with a strong emphasis on implementing existing standards and a strong emphasis on collaboration. Membership is open. Members are primarily businesses, but there are ways to establish associate memberships with other organizations, say like Ag Electronics Foundation, for example. and there's a category for individual memberships. The funding, governance, antitrust, and IP framework are all transparent, which is a big enabler for the companies to be able to interact there. The authority that it has is de facto, so implementation by stakeholders of the standards and guidelines that emerge from it. But output is often handed off to ISO or other de jure organizations when we're doing something that that doesn't exist before. And its expertise is supply chain and field operations business processes. With a series of field operations interoperability initiatives. A fun quote I heard at the Agritechnica last year was Mike Gomes, Vice President of Business Development of Topcon Agriculture, which is one of the big equipment manufacturers, said, AgGateway is the most efficient industry consortium that I've ever seen. So in all this context, how do we tackle the lack of common formats? So there's an increasing harmonization of different manufacturers' implementations of this ISO 11783 standard. And that's a good thing. So it makes it easier for machines to speak the same language of ISO 11783. Problem is that not all machines speak this. And for those that do and for those that don't, AgGateway has come up with an ADAPT framework for format conversion, which is being adopted, and it's quite convenient. It's an open source common data model plus a couple of open source plugins, one for 11783 and another which is a simple lossless serialization that enables farm management information system to farm management information system communication. These plugins convert among different formats and the common data model. All the major equipment manufacturers have made or are making plugins. Others might follow, and anyone can make a plugin really. And the level of adoption and recent awards that it's received suggests that we've reached a critical mass. So common formats is well on its way. The common meanings is a lot harder. So some equipment manufacturers and app writers just don't yet realize we have a problem or don't have resources to engage. And there's a lot of different identification mechanisms, and that's not going away soon. But there is a shared understanding that we need unique IDs, a growing shared understanding that the origin of the IDs is important too. The minting of these IDs, though, tends to be distributed, and centralized solutions don't seem feasible at this time. But there's a growing understanding that at least that minting reference data in CAB is a very bad idea. But every manufacturer has their own controlled vocabularies, and there is some understanding that semantic technologies exist and could help, but this has often been accompanied by bad experiences from the large companies. So there's a perception that ontology building processes are never ending and have little to show for them, and that those systems perform poorly. So what's a possible path forward for industrial agrisemantics? Recognize two valid use cases. One is information preservation. So let's try to identify those products and those operations and the crops and so forth, so that we can enable knowledge synthesis, which is the dream we all have of being able to perform sophisticated analytics and derive insights and inference from the data we're bringing in from the field. So one, information preservation, the other, knowledge synthesis. So what can industry do to enable this? One is understand that information preservation enables knowledge synthesis. So that's basic idea that garbage in, garbage out, right? Keep it simple for information preservation so that there's few barriers to adoption and participation. So we're trying to focus on controlled vocabularies for things like crops and operations and so forth, and on making them easy to use and to adopt. And AgGateway set up an agrisemantics working group for this purpose, with a simple process, simple governance. We also need to take the opportunity to annotate the controlled vocabularies after the fact. So let's match or map these concepts in the controlled vocabularies to ontologies so that we can enable the more sophisticated approach. And we're hearing some success stories about this. Make concept mapping infrastructure available, allow stakeholders to assert relationships, provide standardized APIs and reference implementations for product reference data, enabling different business models to maximize adoption, and most important, don't reinvent the wheel, play well with others. Things like the agronomy ontology, AgriVoc, and establish partnerships with all those of you who have already been doing very valuable things in this space. So with that, thank you very much. And if you want to know more, please reach out to me.